dear Prep 1 students. Hope you are all fine today. In today's lesson we are going to study geometry, polygons. So let's go and start. First of all, I would like you to know that we have been introduced to polygons before when we were in primary 4. We studied the name of polygons according to their sides, and it's so important to remember them and study them by heart. For example, we have the pentagon have 5 sides, quadrilateral have 4 sides, and so on. So we must study by heart the name of each polygon according to its side. What we are going to take extra in Prep 1 is some rules to calculate the interior and the exterior angle. This lesson, the most important thing in it is the rules. You must study the rules by heart to be able to answer any question. So let's go now, and first let's remember what is a polygon. A polygon is a line formed from 3 line segments or more. So first of all, to say that I have a polygon, it must consist of 3 line segments or more. So this means that the smallest polygon according to the number of sides is the triangle. We also said before that any polygon have number of sides equal to the number of angles equal to the number of vertices. So for example, if I have a polygon having 5 sides, this means it's going to have 5 angles and 5 vertices as well. So again, to say that I have a polygon, it must contain 3 line segments or more. And I know that any polygon have equal number of sides, angle, and vertices. Let's go now and see parts of the polygon. We have already studied the parts of the polygon before. Let's go and refresh our memories. First of all, each line segment of the line segments forming the polygon is called a side. So this line I call it a side. This line also I call it a side. Each point resulting from the intersection of 2 adjacent sides, and we mean by adjacent side that they are beside each other. So when I have, for example, here is a side and here it's adjacent side, so this point is called a vertex. The vertex is resulting from the intersection of 2 adjacent sides. Number 3, the sum of sides of all the polygon is called the perimeter of the polygon. If I added up all the sides together, all the length of the side together, I will get the perimeter of the polygon, and this is exactly the definition of the perimeter. Number 4, each line segment joining 2 non-adjacent vertices. Non-adjacent means that they are not close to each other. So for example, those 2 vertices, they are not adjacent. This dotted line that we can see here, it's called a diagonal. So a diagonal is a line joining 2 non-adjacent vertices together. Let's have a look here again and see those 2 adjacent sides. The angle included between them is called an interior angle. And if I come now here and I extended this side, so the intersection here forms an exterior angle. So exterior angle is found outside of the polygon. So let's say it again. This is the side, interior angle, exterior angle, and exterior angles are outside of the polygon, vertices or vertex, and diagonal. Now we have 2 types of polygon. We have a type called a convex polygon, and this is the type that we have studied previously and that we are going to study this year as well. When can I say that a polygon is a convex polygon? A polygon is a convex polygon if each interior angle measures less than 180 degrees. So in a convex polygon, I cannot find an interior angle which is greater than 180 degrees. The other type is called the concave polygon. And in a concave polygon, we must find one or more angle which is measure more than 180. Or in other words, we can say that it's a reflex angle. So I must find the reflex angle which is an angle measuring more than 180 inside of the polygon. As we can see here, this angle is a reflex angle, so I say that this polygon is a concave polygon. What we are going to study this term, and what we have studied before, is the convex polygon. Now, we said before that the interior angles of a polygon are the angles which are inside of the polygon. So let's have a look here. For example, I know that a four-side polygon is called a quadrilateral. I want to know what is the sum of the interior angles of this polygon. So I'm going to draw a diagonal to divide it into two triangles. Now I know that each triangle, the sum of its angles, interior angles, is equal to 180 degrees. Having two triangles, so this means that 2 times 180 degrees equals 360. This means that the quadrilateral, the sum of all its angles, mean the sum of the four angles together should give me 360 degrees. What about, for example, a pentagon? I want to know what is the sum of the interior angles of a pentagon. So we are going to divide it into triangles. I have here 3 triangles, and I know that each triangle, the interior angles of it, sum up to give me 180 degrees. So 3 times 180, this is equals to 540. So the 5 angles inside of the pentagon should sum up to give me 540. And the same goes for the hexagon. The hexagon has 4 triangles, so 4 times 180 equals 720. And same for the heptagon. The heptagon have 5 triangles, so 5 times 180, this is equal to 900. So let's go now, and I have a question. Is there a rule to calculate the sum of measure of the interior angles of the polygon of any side? Of course, in the exam I'm not going to draw and find how many triangles is there inside of the shape and multiply the number of triangles by 180. I can have, for example, I want to find the sum of interior angles of a polygon having 12 sides. I'm not going to draw this polygon to find. Do I have a rule? Yes, I have a rule. How can I calculate the sum of measures of the interior angle? Simply, I do n minus 2, and don't forget to put the n minus 2 between brackets, times 180. And n here stands for the number of sides. So for example, if I have a pentagon contains 5 sides, so I'm going to make 5 minus 2 times 180. And the answer is going to be the sum of the interior angles of a triangle. Now another question. Is there a rule to calculate the number of diagonals of a polygon? Yes. To calculate the number of diagonals, I use the rule n times n minus 3 divided by 2. And again, the n here stands for number of sides. So those are the 2 new rules that I'm introduced to now, and let's go and complete and see the other rules. Now we want to know what's the meaning of exterior angle of a polygon. Exterior, it's outside of the polygon. So let's have a look here at this polygon. Angle 1, this is called an exterior angle because it's outside of the polygon. Now, the exterior angle is from vertices D, or from vertex D. Now, we can find here beside it another interior angle which share the same vertex and they are on the same straight line. So from this I can sum up to the conclusion that an exterior angle plus an interior angle is equal to 180 degrees. So again, an exterior angle and an interior angle, if I sum them together, they will give me 180 degrees. No matter what is the type of polygon, we have the sum of the exterior angles is always equal to 360. So it will not differ what is the type of polygon or how many sides in a polygon do I have. Always the sum of exterior angles is going to be 360 degrees. Now let's go and have a look and see what is the meaning of a regular polygon. A regular polygon is a polygon where all the angles are equal in measure and all the sides are equal in length. So for example, an example of a regular polygon is an equilateral triangle, a square, a regular pentagon, regular hexagon, regular octagon, and so on. So again, to say that a polygon is regular, the measure of all angles are equal and the length of all sides are equal as well. So let's go and see some rules again. In any polygon, we said that the sum of interior angle is equals to n minus 2 between brackets times 180 to find the sum of the interior angles. An exterior angle plus an interior angle sharing the same vertices is equal to 180 degrees. In any regular polygon, each interior angle, if I want to find one interior angle, but it must be in a regular polygon, I'm going to use the rule n minus 2 times 180, the same as this one, but I'm going to divide my answer with n, and again n stands for the number of sides. If I use this equation or this rule, I am going to find the measure of each interior angle inside of a regular polygon. And again, we said that a regular polygon is a polygon where all sides are equal and all angles are equal. If I want to find each exterior angle, we said that the sum of exterior angles is equal to 360. So to find one exterior angle, I'm going to make 360 divided by n, which is the number of sides of this polygon. And the inverse of this rule, if I want to find the number of sides, I can make 360, which is the sum of exterior angles divided by the measure of one exterior angle. Those rules are so important, please, we must memorize them by heart. We said that to find the diagonals, number of diagonals, I make n times n minus 3, all divided by 2. And n also stands for the number of sides. Now, I have two other rules I use to find the number of sides. One of them is 360 divided by 180 minus the measure of one interior angle. So, if I was given the measure of one interior angle and I want to find the number of sides, so I make 360 divided by 180 minus the measure of one interior angle. And if I was given the sum of the interior angles altogether, I'm going to make the sum of interior angles plus 360, and this is all divided by 180. Again, this lesson, it's mainly rules. You must study the rules by heart to be able to answer any question. So let's go now and start solving in our binder, page 51. Here I am given the number of sides, the name of the polygon, the figure itself, and I want to find the sum of interior angles and the measure of one interior angle. Since I want to find the measure of one interior angle, so this is a regular polygon. Let's go now and have a look. Here he told me that I have a triangle, and I know that triangle have 3 sides. So to find the sum of the interior angles, I'm going to use the rule, which is n minus 2 times 180. This is used to find the sum of all interior angles. So 3 minus 2 times 180, this is equal to 180 degrees. If I want to find the measure of one interior angle, so one interior angle, this is equals to n minus 2 times 180, all divided by number of sides again. Let's go now and start solving. So here I know that a quadrilateral have 4 sides, and those names we must to study by heart. Quadrilateral have 4 sides, pentagon has 5, hexagon has 6, heptagon 7, octagon 8, and so on. It's very important to study until the octagon. Let's go back now to the quadrilateral, and we know that the quadrilateral is a polygon which has 4 sides. So the sum of all interior angles, I'm going to use the rule which is n minus 2 times 180. So n here is equal to 4, so 4 minus 2 times 180, this is equals to 360. What about if I want to find one interior angle? To find one interior angle, I use the rule n minus 2 times 180 all divided by the number of sides, which is n. I know here that n is equal to 4. So I have 4 minus 2 times 180 all divided by 4. And this is going to equal 90 degrees. And let's go now for the next one. Here I have a pentagon, and a pentagon has 5 sides. So to calculate the sum of interior angles, I make n minus 2 times 180, n minus 2 times 180, which is equals to 5 minus 2 times 180, which is equal to 540 degrees. To find the sum of one interior angle, again I am going to use the rule n minus 2 times 180 divided by n. And this is going to equal 5 minus 2 times 180 all divided by 5, and this is going to give me 108 degrees. For a hexagon, hexagon is a 6-side polygon. So to find the sum of interior angle, again I'm making 6 minus 2 times 180, and this is going to equal to 720 degrees. And to find the measure of one interior angle, I'm making 6 minus 2 times 180 over 6, and this is going to equal 120 degrees. Do you know? It's easy. We just need to know the rule and apply it. Heptagon is a 7-side polygon. So to find the sum of all interior angles, 7 minus 2 times 180, and this equals to 900 degrees. And to find 1, I'm going to make 7 minus 2 times 180 all divided by 7, and this is going to bring me a decimal. I want to find it approximated to the nearest tenths, so it's equals to 128.6. Going now for number 8, an octagon. An octagon is an 8-side polygon. So to find the sum of all the interior angles, I'm making 8 minus 2 times 180. This is equal to 1080 degrees. To find one interior angle, so 8 minus 2 times 180 divided by 8, and this is going to equal 135 degrees. Let's go now and do number 9, which is a nonagon. 9-side polygon, so 9 minus 2 times 180, and this is going to give me 1260. So the sum of all interior angles is equal to 1260. And if I want to find the measure of one interior angle, 9 minus 2 times 180 all divided by 9, and this is equals to 140 degrees. So each interior angle in a 9-side regular polygon is equal to 140 degrees. The last one here in page 51 is number 10. I have a polygon which have 10 sides. To find the sum of interior angles, I'm making 10 minus 2 times 180, and this is going to equal 1440. This is the sum of all the 10 angles inside of the 10-side polygon. And to find one of them, one interior angle, again 10 minus 2 times 180 divided by 10, and this is equals to 144 degrees. This is the measure of one angle or one interior angle. Hope it's clear now. We now are going to go to page 52 and complete. The sum of measures of the interior angle of a triangle. I know that a triangle is a three-side polygon. I want to find the sum of measure, so I am going to use the rule n minus 2 times 180 degrees. This is equal to 3 minus 2 times 180, and this is equal to 180 degrees. So the sum of measures of the interior angle of a triangle is equal to 180 degrees. Now going to number 2, I want to find again the sum of measures of the interior angle of a square. A square is a four-side polygon. So again, sum of measures, so I am using the rule n minus 2 times 180. This is equals to 4 minus 2 times 180, so this is equal to 360 degrees. In number 3, I want to find the sum of measure of a hexagon, interior angle of a hexagon. And I know that a hexagon is a polygon which have 6 sides. So I'm going to make n minus 2 times 180 because I'm looking for the sum. So 6 minus 2 times 180, and this is equals to 720. Now he is asking here for the sum of measures of the exterior angle. We said that the sum of measure of the exterior angle, regardless of the number of sides I have, is always equal to 360. So in number 5, the sum of measures of the exterior angles of a pentagon. Again, exterior angles of a pentagon. So we said that the sum of exterior angles of any polygon is equal to 360 degrees. Let's go now for number 6. The sum of measures. I need to find the sum of measures of the interior angles of a decagon. So sum of interior, so I'm using the rule n minus 2 times 180. And a decagon is 10 sides polygon. So 10 minus 2 times 180, and this is equals to 1440 degrees. This is the sum of measures of interior angle. And in number 7, sum of measures of interior angles of a pentagon. The rule for the sum of measure is equal to n minus 2 times 180. And here a pentagon, it's a 5-side polygon. So 5 minus 2 times 180, and this is equals to 540 degrees. Number 8, he's asking here about the number of diagonals in a quadrilateral. We said that the rule we use to find the number of diagonals is n times n minus 3 all divided by 2. So n here, quadrilateral means it has 4 sides. So here I have 4 times 4 minus 3 all over 2. This is mean I have 4 over 2, which is equals to 2. So the number of diagonals here is 2. And it's so easy to know that a quadrilateral have 2 diagonals only. So let's memorize it as well. Now let's go for number 9. The sum of measures of the interior angle and exterior angle at a vertex of an octagon. We said that an interior angle plus an exterior angle sharing the same vertices, their sum is always 180 because they are adjacent supplementary angles. The same for question number 10. The sum of measure of the interior angle and exterior angle at the vertices of a pentagon. It will not matter. The interior angle plus the exterior angle at a vertex, this is equals to 180 degrees. Now let's go for number 11. The perimeter of a regular polygon equal to 60 centimeter and its side length is equal to 10. Then the measure of each angle. We said that the rule to find the measure of each angle is n minus 2 times 180 divided by n. So I must first to find n, and I don't have here in the question n. So what should I do? I only have the perimeter, which is 60, and the number of and the side length, which is 10. Can I use those two information to find n? Yes, simply n in a regular polygon is equal to the perimeter divided by the side length. So again, to find n in a regular polygon, I make the perimeter divided by the side length. So this is equal to 60 divided by 10, so it has 6 sides. Now I'm going to go and substitute in the rule, knowing that n is equal to 6 sides. So I have 6 minus 2 times 180, and it's all divided by 6, so this is equals to 120 degrees. In number 12, if the measure of the exterior angle of a regular polygon equals 60, so one exterior angle is equal to 60, and it's a regular polygon, and this means that all interior angles are equal and all exterior angles are equal. Now I know that in a polygon the sum of exterior angles is equal to 360, and each one of them is 60. So to find n here, I'm going to make the 360, which is the sum of exterior angles, divided by the measure of each exterior angle. So I will have this equals to 6. So now I know that it's equal to 6 sides. Again, because this is a regular polygon, so this means that all exterior angles are equal and all interior angles are equal as well. I know that the sum of exterior is equal to 360, and I want to divide them equally according to the number of sides. I know that one of the exterior angle, or each one of the exterior angle, is 60 degrees. So to find n, I am making 360 divided by 60, and this is equal to 6. So number of sides here is equal to 6. And the polygon which has 6 sides is called a hexagon. Now let's go for number 2. Find the measure of each interior angle in a regular polygon, whose perimeter is 40 and the side length of each one is 5 centimeter. Again, we said that to find n, I am making the perimeter divided by the side length. I have here the perimeter equal 40 and the side length equals to 5. So the n is 8 sides. I have the number of sides equal to 8. Now easily I can go and find the measure of each interior angle using the rule n minus 2 times 180 divided by n. So this is 8 minus 2 times 180 divided by 8, and this is equals to 135 degrees. So the measure of each interior angle is equal to 135 degrees. Let's go now for number 3. If the measure of the interior angle, so here I am given one interior angle and it's a regular polygon, this is equals to 150. So one interior angle is equal to 150. Find the number of sides of this polygon. In the beginning of the session, we said that we have a rule to calculate the number of sides. And if I was given the interior angle, the measure of one interior angle, so n is equal to 360 divided by 180 minus each interior angle. And this is a rule that we must memorize. So here n is equal to 360 divided by 180 minus 150, which is equals to 12 sides. So this polygon is equal to 12 sides. And let's go now for number 4 in the next page. If the measure of an angle in a hexagon is a 6-side polygon. So I know that one of the angles of the hexagon is equal to 130 degrees. Then find the sum of the other 5 angles. So let's draw it here. I have a hexagon and I know that one of its angle is equal to 130 degrees. I want to find the sum of the other 5 angles. We know that we can use the rule n minus 2 times 180 to get the sum of all interior angles. Knowing that a hexagon has 6 sides, so 6 minus 2 times 180, this is equals to 720. So this means that the 5 angles, if I add them together, I am going to have a sum of 720. I have one of them equal to 130. What's going to be the measure or the sum of measure of the other 5 together? Simply the sum of the 5 angles is equal to 720, which is the sum of all the 6 together, minus 130, which is one of them. So this is going to be equal to 590 degrees. The sum of the 5 is equal to 590 degrees. And take care, since he didn't say that it's a regular polygon, I cannot assume that it's a regular polygon. Now let's go to number 5. In the opposite figure, measure of angle B is equal to measure of angle D is equal to 90, measure of angle A equal to 95, and measure of angle E is equal to 135. Find with proof measure of angle C. So here we want to find measure of angle C by proof. The first thing that we should go and think of is, what is the number of sides here? We have 5 sides, and 5 sides, this means that this is a polygon, a pentagon, sorry. So we must write that since A, B, C, D, E is a pentagon, yani it has 5 sides. Since it's the pentagon, so therefore sum of interior angles equals n minus 2 times 180. I'm finding only the sum. So 5 minus 2 times 180. So the sum is equals to 540 degrees. So now I know that A plus B plus C plus D plus E, all of them is equal to 540 degrees. Now I have all the 4 and the 5th one is missing. I have 135, 95, 90 and 90, and this is only is missing. The 5 of them, when I add them together, I should get 540. So how now can I find C? Exactly 540 minus the sum of the 4 angles that I already have. How am I going to write it? I'm going to write since measure of angle B equal measure of angle D equals 90 degrees, measure of angle A equals 95 degrees, measure of angle E equals 135 degrees. So therefore measure of angle C equals 540 minus 90 plus 90 plus 95 plus 135. So angle C is equals to 130 degrees. So again, I must mention first what is the type of this polygon according to its side, find the sum of the interior angles of this polygon, and then see what I want to do. And now let's go for number 6 and the last question in today's session. In the opposite figure, measure of angle DFE is equal to 40, measure of angle DEF equal to 55 degrees, measure of angle ABD is equal to 80 degrees, measure of angle BAC is equal to 65 degrees, line segment CF intersect line segment BE at point D, find with proof measure of angle ACD. So let's go first and have a look at the drawing which we have. This drawing, it's divided into two parts. I have a triangle and I have another four-side quadrilateral which is called a pentagon, which is called a quadrilateral. So I want to find this angle. In the quadrilateral I have two angles missing, angle ACD and angle CDB. Two angles are missing, so I cannot find one of them. I'm going now to look at the triangle. I have two angles and one angle missing, so it's easy for me now to go and find the third angle in the triangle. So I should write in triangle DEF since sum of measures of interior angles equal 180 degrees. I know that a triangle, the sum of interior angles is equal to 180 degrees, and since measure of angle DFE equals 40 degrees, measure of angle DEF is equals to 55 degrees. So therefore the missing angle, measure of angle EDF is equals to 180 minus 40 plus 55. So this is equals to 85 degrees. I know now that this angle is 85 degrees. Now let's have a look here. Those two lines, they are intersecting lines. And we know from last term that intersecting lines form vertically opposite angles. So this means that this angle, which is 85 degrees, is going to equal this one because they are vertically opposite angles. To write vertically opposite angle in proof, that's so easy. Since the two lines are intersecting, so since CF intersect BE equals set D or point D, so therefore measure of angle CDB is equal to measure of angle EDF equal to 85 degrees vertically opposite angle. So those two sentences we always use to prove that we have vertically opposite angle, or to write a proof that we have vertically opposite angle. Now I have this angle, angle A 65, angle B 80, and I know now that angle CDB is equal to 85 degrees. So now I have three angles in a quadrilateral and I want to find the fourth one. Is it easy? Yes. First, go and find the sum of the quadrilateral. So I'm going to write that since ABCD is a quadrilateral, I knew that it's a quadrilateral because it has four sides. Since it's a quadrilateral, so therefore the sum of interior angles equals n minus 2 times 180 equals 4 minus 2 times 180 equals 360 degrees. So the sum of the four angles is equal to 360 degrees. Now, since measure of angle ABD equals 80 degrees, measure of angle BAC equal to 65 degrees, measure of angle CDB equal to 85 degrees. So now, therefore, therefore, measure of angle ACD is equal to 360, which is the sum of the interior angles of a quadrilateral minus the sum of the other three, 80 plus 65 plus 85. So this is equals to 130 degrees. By now we have finished today's lesson. It's so easy. It's just about the rules. We need to memorize them by heart, and you're going to find that this lesson is so easy. I would like to thank you all, Prep 1, and have a nice day.